For our first cs224n assignment, we're going to review list comprehensions. And this video is going to cover a common problem that I keep on repeating, and that's to use Stack Overflow when I run into a list comprehension. And that just doesn't work. And it doesn't work because I'll cut and paste a solution, I won't think about it, and then when I need to get a more complex variation based on something I just cut and paste, I get lost and then cut and paste again, and I'll spend an inordinate amount of time looking for something that I should have known and was obvious if I had not done the Stack Overflow search to begin with. So let's start with a derivation of how list comprehensions work, some simple cases to build up the theory and to refresh our memory, and then we'll figure out how to do the more complicated cases from there, which would seem obvious, and we'll save a lot of time as we get down to more complicated examples of list comprehensions. And this is important because as we get deeper in the assignment, it'll be a lot easier and faster just to be able to get things to work the first time. And we can only do that if we go through this derivation process. Okay, so let's start with a test array, a one-dimensional array with 6 elements, and we're just going to print out, we're going to do a loop in Python for x in R, and we're going to print out x. And so this prints out each element of the array. And to do this in a list comprehension, the equivalent would be we would mention the element. Well, let's loop through, let's copy the syntax first for element in R. This is the same as a loop, and now let's print out element. And so this will print out each element here, which corresponds to visiting each element in our loop here. So let's get rid of this. Okay, so what else can we put here in element? Can we put ARR? And will that return a list every time? Yes. So instead of returning an element, we can return an R. What else can we do? We can do constants, anything that's in global scope. What else can we get to? Okay, so this is cool. This kind of makes sense. So now let's print out each element. So now if we need to add an if statement, we would put the if statement in here, right? If let's do an actual code run. If x greater than 3, then let's print x. So this should give us a loop that will run and print out all the elements above 6. And so let's repeat this in the list comprehension. So right now we're looping through each element, and then if element is greater than 3, we'll return element. And so let's get rid of this. Okay, so we're good. We have an equivalence. So now the next question becomes, how do we do a double loop? So let's do this. For sublist in R, now we have sublist. So for element in sublist, print element. And so this double loop will print out all these elements. Okay, so that works. So now how do we translate this into a list comprehension where we visit each element with a double loop? And so it turns out we don't know what we're going to return here, what's element going to be. So let's just copy this syntax verbatim. So let's put the outer loop first in the leftmost position. So for sublist in R, which is here, let's add for element in sublist. So if this syntax is correct, which we've just copied the double loop, what do we want to print out here? So we want to print out element, right? Element. Okay, so that turns out that works. So now we have a rule which says that we can copy verbatim the loop structure in a non-list comprehension format, and we can simply verbatim move these for loops starting with the leftmost position in a list comprehension. We'll be able to replicate what a list comprehension does. And so this achieves our flattened output, which is what we want in this. And then once we have our flattened syntax, which is the most confusing part, we can just nest all the other functions of what we need to do. So first, write out how this works without a list comprehension. So we need a double loop, and we need to store this into another array, into a flattened array. And then we can run a set to remove the duplicates, and then we'll convert the set into a list, and then we'll sort them. And this sorted function will create a copy of the elements versus just calling sort and doing an in-place sort. And then we return the result. Okay, that's it for this video.